year is, first of all, is the customer outages, and the second is memory usage, and we had to cut that short given time constraints. Then I'm happy to take questions. A brief history about me. I joined GitLab.com as a user on October 2014. I want to give everyone a heads up. I do have a evil twin brother. So people have asked about cloning me, but I am not the same person as this person, Roger, who you can link to him. He did send me a merge request a few months ago out of my surprise. Sometimes I merge his code. But other than that, I joined full-time GitLab in 2015 and bounced around different roles, grew the team, helped grow the team to about 150 before handing off the reins to Eric. And now I focus most of my time on the hard technical challenges we have as a company. So what exactly do I do here? And that's a very good question. I can talk, there's a great job description link about what the engineering fellow role is about. I can talk more specifically about what I've been doing this past year. And the first thing I want to talk about is these customer outages. As Sid mentioned earlier in the month, customer outages are our outages as well. And I got pulled into this about 2 weeks into the problem. So a little bit late on our side getting into action, but essentially the customer was running into a really bad issue where access to GitLab was really slow. This was, load pages were taking 30, 60 seconds or not even coming up at all. This was just a core problem for the day-to-day business. And they upgraded from GitLab 10.8 in mid-January to 11.5, and they experienced okay performance about a week, and then maybe 2 weeks into deployment, it was almost unusable. And so you can see in this graph they shared with us is the load average, basically measurement of how many processes are waiting to do something, jumped from, it was usually under 5 on any given day, it jumped to over close to 20 at peak times. And so this is a symptom of part of the problem. And what changed between 10.8 and 11.5? Well, as most of we talked about is moving away from NFS, and fundamentally we changed the way we access Git data. So in 10.8 on the left side, we had anytime a request came in, we went through the Unicorn process. Unicorn actually talked to the NFS server directly via this rugged API. You'll hear that term a lot. This is basically a Ruby library that accesses Git data and provides an interface to access Git data. And so we were doing a lot of direct access on the NFS server, and some of the requests are going through Gitaly, but for the most part, most of it is going directly from Unicorn to the NFS server. When we upgraded to 11.5, we moved away from that model where we basically abstracted most of the Git data calls, almost all the Git data calls, in fact, to the Gitaly service. So every request that came from GitLab, anything that touched Git data had to go through Gitaly, and that's what you see on the right side. And Gitaly, in turn, either talk directly to NFS server, or in GitLab.com's case, we actually talk directly to the disk. So that's a fundamental difference that I'll get to talk to more about going forward here. And so when we logged into the customer's instance, we saw this. We saw many of these Git processes running, and many of them stuck in this D state. On the fourth column, you see this D everywhere. And what that means is these processes were essentially just waiting to hear back from that file server, the network file server. And that's what caused the high load. And so if we look under the hood, what exactly happened and what happens when you actually make a request? So I'll take an example. Let's say you push a new branch called my feature. Unicorn, the very common thing to do is say, okay, I need to look up that commit to see if that branch actually exists. So what it does is issue this find commit request. Gitaly then turns that around and spawns this new Git process, this Git cat file process on the second step. And that involves a bunch of different little IO operations to read your configuration files and so forth. And that takes about 40 different operations. And then once it gets that answer, it'll come back to the application to say, yeah, this branch is commit. So 1, 2, 3, 4, whatever the SHA ID is. So on GitLab.com, that takes less than 10 milliseconds on any given, most 99th percentile of the request. For our customer, this is actually taking close to 500 milliseconds, about 375 milliseconds. So that's an eternity if you think about this model. This is a very common graph of what is timing in this world. So on the most important thing is to look on the right side, because this is sort of when we get to the disk access. So you can see, like on the right side, there's a packet from California to the Netherlands, round trip takes about 150 milliseconds. So that's, we're talking about 375 milliseconds, 150 milliseconds is it's a transcontinental packet. That should be considered eternity for us, and that's kind of fundamentally the problem that we're having, because when you imagine this at scale, you get enough requests, things bog down, things get really slow, and that's basically what was happening for our customer and for other customers as well. And so what I really want to underscore here is that basic performance, not just optimal performance, it needs to be a top priority for a company, because this change that we made was great for GitLab.com, but it was not great for customers using NFS. And this is what, this is the reference architecture we've been giving to customers for a long time, and we haven't switched them off NFS because there isn't the alternative. And I'll talk about the alternative later, but I want to underscore this is more than just a Gitaly team responsibility, because it's not so much Gitaly's fault, it's how the backend is using Gitaly, right? For example, we should only have to issue one request to do certain things. We shouldn't need 100 of them, and that's fundamentally the problem here. So how do we fix this? Well, the first thing we need to do is sort of bring back the original functionality, the functionality that used this rugged API under a feature flag, so customers using this can enable this mode. And that's what we've done. That's what I basically focused on the last month, getting this in, because it's a priority for this customer and other customers as well. There is a now feature flag in 11.9. You can look at the documentation that will enable a bunch of these feature flags for customers using NFS. But the way we really solve this is to optimize these queries. So you'll hear a lot about N+1 queries. Well, N+1 is really a name for a case where you're just issuing way too many queries. And I can talk about the details why it's called N+1, but basically we need to optimize this down and get it to the point where we only need maybe one request or maybe two, not 100, not 150, and so forth. And the third main takeaway is that, even though we've been testing heavily on GitLab.com, it used to be GitLab.com was a representative environment. It used to be that if it worked on GitLab.com, it would work for customers. That is no longer true. And there's a number of reasons why. So for example, we're using solid state disks. Most of our customers are still using spinning disk with NFS on top of it. And the way we're accessing it is very different too, right? We've gotten rid of NFS for the Git repository data. Customers have not, and we're directly accessing the storage on this disk, so you get much better performance. So if you look at this graph here, we're actually talking about this blue section here, where any access on solid state is probably in the microsecond time frame. We're using a much more powerful cluster. We have way more CPU, way more RAM, and a lot of customers are just using a single instance to have all the services running at the same time. So, and you'll hear a lot about Gitaly high availability. That's really the solution to get customers off network file system. But until that's available, we need to do everything we can to test and make sure that GitLab still works well with NFS, even though it is considered sort of our legacy infrastructure. That's really the main points I wanted to highlight. And before I shift gears, and I don't want to spend too much time on the memory usage because I've already taken 8 minutes, but basically I did some investigation over the weekend to figure out, well, how much memory, and when we talk about memory usage about GitLab, we have to talk about two different things: baseline memory and runtime. The baseline is sort of like a hot air balloon that's sitting in your garage that's uninflated. It's how much space it just occupies just by doing nothing. And this is sort of the graph over time of how much baseline memory has been used. And so you can see what was surprising to me is that it increased from 8.14 to 9. We integrated CI in there, but since then it's increased, but it hasn't increased month over month, which is, I suppose, a good thing. I don't know exactly why yet, but it is interesting to me that while it's increased, it hasn't been this linear progression as I expected. And there's a bunch of different graphs I can talk about specifically. They're pretty self-explanatory. There's a LinkedIn issue about more details about these things. But I sort of want to open up the floor to discussions about memory usage, customer outages, and so forth. So I'll turn it over to the floor here. And I think the first question I have is from Rachel. What is the next step in deciding if Puma will help? That's a good question. Really, we need to get metrics integrated with Puma, because we're shipping Puma right now in experimental mode in Omnibus. You can enable it today. But that doesn't do you any good unless you actually can measure how many workers you need, how many threads you need. So, that will really determine how much memory you use. If we need as many processes as we do today with Unicorn, that's not going to save us any memory. We need a lot more threads than we think. Then it could add up to more memory. So we really have to experiment with the right values there, get the metrics in, do a lot of testing to see what works for us and how much RAM that's going to take. Sean, very niche question. Do we know why delete diff file works with max allocate is so high in slide 16. That's a good question. I haven't drilled into that specifically.
Yeah, sorry, Stan. I don't expect you to like answer this in the call necessarily, but just because I saw that up there, and then I was like, I know what that worker does, and I was like, that seems really high for something that does basically nothing. So it made me sort of wonder if the measurements.
It's possible. I mean, the way we're
There's an
measuring is
issue there.
yeah, so we could link an issue. I think it's possible the measurement is off because there may be other things going on that throw off that measurement, but sometimes you'd be surprised. You might actually, if you actually profile, you might actually see it do something really silly. So that's sort of that's the nature of memory optimization.
Okay, thanks.
Philippe, we are seeing a lot of bugs related to NFS. Do we still have an environment using NFS? We still use NFS to a limited extent, but not for Git repository data. And I think Jarv mentioned there's an issue there to bring up a test bed to use NFS specifically to test this problem that we saw with customers. Simon, if GitLab is a representative customer experience, how do we QA for customers effectively? Can we specify how they should deploy? Yeah, that's a good question. And this is sort of brings back to the point of spinning up an environment that's more representative. And I think that's the issue that Jarv was talking about 6194 here. Yeah, the test bed for on-premise. Yeah, essentially, either we have to dog food, this configuration, or we have to have an environment that actually simulates our customers' environments. We have recommended to customers to have direct access, but a lot of that is not a non-starter because we don't have Gitaly high availability. So they're gonna want to use a NFS appliance that has redundant features, for example. Is there an issue to discuss how we can detect these performance changes for reference actually? Yes, so there's links, issues there. Thanks, Brendan, for chiming in there. And that goes to our testing. And I think the slide, that 6194 issue that Jar linked as well, talks a lot about that, of specifically what do we need to test, how do we need to test it to give confidence. And then I think the goal is to get as much data before we sent this to the customer and say, hey, we've tested this X, Y, and Z. We can help you test it on your staging environment as well to validate that we're consistent here. If we bring direct access using rugs, does that mean we need to fix a bunch of bugs and timeouts that we see? That's a good question. We may need to do that. I mean, I'm hoping that the feature flags that we have can just be enabled, and it worked before for our customers. We think we had the circuit breaker in place before, and I don't think we've actually ever enabled it for customers. So I don't see that as high priority, but it is possible we may need to do some minor fixes if we do see issues. Should we move GitLab.com to spinning disk also because it saves costs? That's a good question. It may harm performance, obviously, and it will be cheaper, but it may harm performance. But it will be cheaper. So I think Jarv mentioned we're doing this for
Can I add something to that as well? Yeah,
sure.
I mean, we could totally do that, and certainly with all the cloud spend issues that we're seeing at the moment, it's definitely something that we need to consider. But the big problem is, like, the classic outage that we used to see in Azure was basically all of our Unicorn workers, or this could be Puma as well, it's not Unicorn, it's just the front-end fleet, get saturated with requests that should be taking 1 millisecond to go to a Gitaly server, and that Gitaly server is overloaded, and those requests are taking like 1,000 times longer than they should. And very quickly, the entire fleet is bogged down with requests to that one server, and then everything falls over, and you start seeing 502s everywhere. And so one of the things that we could do to bring down cloud spending is switch some people over to magnetic disks and have other people on SSDs, like premium clients and non-premium clients. But the thing that we would definitely need before we did that is like a really good circuit breaker, maybe built on top of Envoy, instead of building it ourselves, like actually just use something that's out there ready. And so when we have a slow Gitaly server that's got spinning disks, we can just cut it off and just have 500 errors for that particular Gitaly server without bringing down the entire cluster. I don't know if that makes any sense, but that's how it sort of works in my head.
Yeah, that's absolutely right. And I think that's the reason why that we were hesitant to do that. I mean, I think that's why we were considering the circuit breaker functionality, right? But there was an issue. Yeah, basically, if you tie up any of the disks for a long time, it can harm the entire fleet. Would you mind reading the questions a little more slowly? Sure. There is a there is a Google Doc if you're not aware of that. There seems to be a lot of conversation. Do other people want to talk about this spinning disk?
I'll just chime in a bit because I put the question there, but and the costs of GitLab.com are way higher than they should be. And we moved to SSD just because availability is number one, but we got availability fixed now, and putting every single repo on SSD, that's never gonna make GitLab.com sustainable. So we have to get away from that. And I think our thinking should not so much be who's a premium customer, because if we have like an open source repo that gets lots of I/O, that should probably be on a magnetic SSD as well. So probably should be looking at what's used and what's not used. And that should probably go from SSD to magnetic disk to maybe even object storage, where you retrieve it first from object storage. If you haven't used the repo in over a year, that might be a good trade-off for us to make. And I think we should start looking into that and figuring out how we can move things between servers automatically based on how much something is used.
So Java and I were talking about this morning, and we were trying to work out like what percentage of the GitLab fleet has been used in of the Git repositories have been used in the last 6 months. And you'll probably find it's about 10%. And so if we could take the rest of those and sort of cold storage, put them in object storage, and provided we can load them up in a minute or two, like I think that would be a huge saving.
I think that would be amazing. And I think that would totally work. And so maybe magnetic disk is not the answer. Maybe that is the answer. Just get rid of the 90% that is not being used for last half year. Someone access it, we show, hey, sorry, retrieving your reactivating your repo because it hasn't been used in 6 months. I think that's totally legitimate.
Yeah, this is a great suggestion. It's almost like cache promotion, right? That's the classic model.
There's yet another question about this topic from Gabriel. If it would make sense to use magnetic disks for read replicas if we have Gitaly HA. To answer that, I don't think it is an option to do that, because if you want to fail over to another node and it only has magnetic disk, then your performance will degrade as well. So you have long-lasting effects of one node having network partition or something else. So the suggestion by Sid of moving stuff to like S3 or other object storages, or having those 90% on magnetic disk would make more sense in my mind.
Okay, thanks for that, ZJ. Brendan, how do you consume so many issues so efficiently? It seems sometimes that you are everywhere. You sometimes get to verify issues before myself with EMs. Yeah, it's a good question. I subscribe to a lot of issues, and if I can be helpful and I see something that I can be helpful very quickly, I will chime in. There's no other secret sauce than just being able to check my email quickly and respond quickly. It does help that I type pretty quickly. I've been typing since the age of 4, so at times I can type over 120 words per minute, so that helps. But generally, I just putting in the time. Rachel, do you have any concerns about scaling the architecture of GitLab? Other concerns? I don't have any concerns that we haven't discussed before. I mean, obviously, memory usage is a thing that's top of mind as well. I think that there are a lot of things we need to do to improve the memory performance and just efficiency, because that is, performance and memory usage are probably the top of mind things here, right? Memory usage is something that doesn't get as much attention, especially runtime memory, because it's easy to write something that just uses 16 gigabytes of RAM, as I showed in one of the slides here. This thing we were using 17 gigabytes for a long time and nobody noticed. And I came in and spent a week and finally figured out it was something we didn't need to do. So we need to do more things like that, where we're constantly evaluating and benchmarking what we're doing, because one of the things that's happening constantly on GitLab.com and in our customers is that Unicorn and Sidekick workers are constantly being restarted because of memory, and that shouldn't be acceptable to us, because no process in enterprise world has to restart constantly to recover from memory leaks. I mean, that's just something I've tried to fix, but it's a really hard problem in general. So we may need to think about more dramatic solutions, like rewriting certain parts of GitLab in a language that doesn't use as much memory, or just is way more performant. But that has to be addressed on a case-by-case basis. When we recommend an HAA architecture, we strongly encourage NFS. Should we instead try to encourage the community not to use NFS, especially we published Gitaly, this blog post about Gitaly? It's a good question. I mean, we're strongly encouraging NFS to customers, the enterprise customers, right? And a lot of enterprise customers have a solution for like an NFS appliance that is fault tolerant, right? So if a single hard drive goes down, they can recover from that. It may be, if we recommend Gitaly as the only way, that may raise some questions about, well, how fault tolerant is this? And I'm not sure if that's what the default we should recommend. I mean, obviously for people who are not concerned about availability and they care more about performance, that may be the worthwhile trade-off. But I think it'd be hard for us to say for our major customers to say, don't use NFS until we have a Gitaly high availability solution. That's my personal opinion. I don't know if other members have an opinion there.
Yeah, I was going to agree, Stan. I think that, and coming from the world of services with our customers, that's exactly it. Is they, don't have a team that's going to run, take care of availability like our team does on GitLab.com, right? We can accept a shard that we have to, take care of and feed and water and get back online. Whereas for customers, that's not acceptable. And so they want to have, a device take care of that for them.
Yep, Sid, slide 15 to 16 shows much less memory usage from GitLab 11.5 to 11.6. Does this reduce the recommended memory requirement at GitLab from 8 gigabytes? I would hesitate to say that, because Sidekick takes 2 gigabytes of RAM. There's a lot of other things that take RAM, right? So the thing that often takes RAM is actually the Git process itself. We forget, if you do a Git clone at the Linux repo, which a lot of people like to do, that can take 2 to 4 gigabytes of RAM just by itself. And so when you start to think about all the different things that need to run, yes, this helps, but there's other things that also need to run. And then, as I see in the next case, this is GitLab.com, obviously, and we're doing things that other customers may not be doing as frequently. Things are higher today. It's like, for example, the export worker, you can see, is using anywhere from 4 to 5 gigabytes of RAM, the import worker. So even though customers may not be using this functionality as much as we are on GitLab.com, they may still hit these barriers when they do something. And so we have to just have enough headroom for them to function. Now, if they're doing very small repos, not doing a whole lot, yeah, I think 4 gigabytes might work. But once you start doing more interesting things, it's very easy to hit these memory limits. Yeah, and the baseline is obviously if it's over 2 gigabytes, if your Sidekick is using 2 gigabytes, you're already hitting 4 gigabytes, leaving room for very little.
I have a maybe naive follow-up question. What about turning off certain GitLab features? Is this something that could help? And is this something we would want people to be able to do, or does it go against our single application philosophy?
It'll certainly help in some cases, right? If you disable export import, right, that will at least potentially knock off this graph from having the top two things, right? There are, some of our memory usage is just due to code size and our dependencies. We have close to 1,000 gem dependencies on top of our own code. So that all that code gets loaded into memory, and also it contributes to our, this is sort of the picture of that here. I didn't get a chance to talk more about it, but a lot of that red corner there, 30% of our code is just instruction sequences from Ruby, right? That's just code that's going to grow that over time unless we do something to optimize the interpreter or our own code. So that will help, but I don't know if you can only do so much. So if you do disable code, it'd be nice if you can compile it out. That would help. If you could disable it outright so that you don't hit these memory usage, that would help. But it's very tricky to kind of optimize it completely, right? Without you might, our mantra is to have an application that just works out of the box, that has the reasonable settings. So I think it's hard to just start tuning different things to get just under the memory performance. Now we know this is a problem with certain things, but for the most part, like for example, Git garbage collect worker takes 2 gigabytes of RAM. We don't actually control a lot of that because that's the Git process doing its thing on large repos. So it's hard to just, memory box that. But yeah, I think it does kind of go against like our application just working out of the box. It should just work efficiently without us having to tune so many feature flags. How much of your time is spent in fixing things upstream? When you say upstream, do you mean GitLab upstream or other?
No, I mean like our dependencies that you've mentioned, for example.
That's a good question. I don't know the exact number. I do spend a lot of time looking at upstream things. I've fixed things in Rugged and libgit too. I've fixed things in even Docker. But I think it's a small percentage in things in GitLab itself. I think that if I were to just guess, I spend probably 90% of my time looking at GitLab code and maybe 10% on upstream things. But sometimes in January or last year, I had to look at the kernel really closely for NFS issues because our customer was running an NFS. So that month I was spending, 50% of my time looking at kernel code. All right, any other questions I can answer? Okay, thanks all for your time.